Hello, everyone. Welcome back to our channel, where we explore the fascinating world of ETL testing. In today's video, we'll be discussing some commonly asked interview questions from one of the latest interview and their detailed answers. So, if you're preparing for an ETL testing interview, you're in the right place. Let's dive right in. And the first question is, how do you validate data types in ETL? Okay, we will see the answer for this question. First, we will understand question, and then we will jump into solution. So, validating data types in ETL is a crucial step to maintain data quality and consistency. In ETL, we often deal with large data sets from different sources, and these data sources may not always have well-defined and consistent data types. To validate the data types, we can use SQL queries against the metadata of the tables. Sounds interesting, right? Will you show us how this is done? So in many database management systems like Oracle or MySQL, we can retrieve table metadata using the describe table name command. Okay, for example, let's say we have a table named sales that we want to validate. We can write SQL query using describe command. Let's write the query describe and table name. So this query will give us information about the columns and their respective data types in the sales table. Now we will run this query and see the result. So as you can see the result, it's showing the column name, data type, length for character types, and other properties of each column in the table. All right, now we use this information to validate the data types in ETL testing. For example, let's imagine you are working for an e-commerce company and your task is to validate the sales date which is already extracted from old sources and transformed. The data includes information like customer sales ID, date, and price. So, to validate data types, you want to make sure that the data in the new database matches the expected data types. So, once we have the metadata, we can compare the expected data types with the actual data types in the ETL process. Here, I will write an SQL query to extract some sample data from the sales table, which is already transformed. For example, in this table, if we expect the price column to be of type numeric, we can check if all the values in the price column are indeed numeric, and we'll compare this with source data with another SQL query. Once you have run the validation queries, you should review the results to identify any data type issues. If you find any discrepancies, you need to handle them accordingly. Data type validation is just one of the many data quality checks performed in ETL. By ensuring that the data types are correct, we minimize the risk of data inconsistencies and errors downstream. So data type validation is a crucial step in any ETL process. And that's it. Let's jump into another interview question. And the next question is, write an SQL query to identify duplicate records in a table without functions. Let's understand this question first, and we'll see the answer. Here, they asked us to identify these duplicates without using functions. How we can do that? So we can write an SQL query to identify duplicate records using functions. We already explained one interview question about identifying duplicate records in our previous video. But we wrote the query using SQL functions, like row num and row ID. But in this query, we are not allowed to use these. All right, let's see how we can write an SQL query for this. For example, we have a table called customers, and we want to find duplicate records in this table. Let's write the Oracle SQL query step by step to find those duplicates. First, we start with the select statement to retrieve the columns we want to display for the duplicate records, and first underscore name, last underscore name, and department, and group the records based on the columns that we suspect might contain duplicates, which are first underscore name, last name, and department. And now the having clause is where the magic happens. We use the count function to count the number of rows in each group. If the count is greater than 1, it means there are duplicates in that group. Next, we write an outer query to find the duplicate records from this inners query. Outside the subquery, we use the same customers table and select the columns that we suspect might contain duplicates, which are first underscore name, last underscore name, and department. And we use the where clause in the outer query helps us join the original customers table with the subquery result. And we use the in operator to filter the rows in the original table where the first underscore name, last underscore name, and department have values that match the duplicate groups identified in the subquery. Now we will run this query and see the result. And there you have it. And we've successfully identified duplicate records in the customers table using this simple Oracle SQL query without using any functions. Understanding how to find duplicates in a table can be extremely useful in various data analysis tasks. That's it. And as always, feel free to leave any questions or topics you'd like us to cover in the comments section below. I hope you found this video helpful. If you please give it a like and subscribe to our channel for more exciting tech content. Next, we will jump into another ETL testing interview question. And the next question is, write an SQL query to identify those teachers who only teach mathematics and no other subjects. All right. Let's begin by understanding the scenario. We have a database with a table named teachers_sub, which contains information about various teachers and the subjects they teach. We want to find teachers who only teach mathematics. No other subjects. Let's have a look at this table's data. Here we have 3 teachers and each one teaches one subject except Michael, who teaches mathematics, and science. But as per the question, we want to find teachers who only teach mathematics. No other subjects. Let's find out how we can achieve this. We'll begin writing the code step by step to understand it better. First, we want to retrieve information about mathematics teachers from the teachers table. So we start with the select statement and columns names, teacher_ID and teacher name. And now, we specify the table we're working with, which is teachers_sub, and we'll give it an alias, T1. Next, we want to filter only the rows where the subject is mathematics. We do this using the where clause. Now comes the interesting part. We want to exclude teachers who teach any subject other than mathematics. To do that, we use a not exists subquery. The subquery will check if there's any record in the teachers table, aliased as T2, with the same teacher ID as T1, our outer query, but having a subject different from mathematics. And that's it. This SQL query will fetch us all mathematics teachers who teach only mathematics and no other subjects. Let's run this query and see the outcome. There you have it. We have the result who teaches only mathematics. And also we have another way of writing an SQL query using case statement to find teachers who teach only mathematics and no other subjects. Let's have a quick look at the another query using case code. And here's the SQL query that will help us achieve this. Here in this query, the given SQL query selects the teacher ID and teacher name from the teachers table and groups the records by teacher ID and teacher name, and filters the results using the having clause. The sum and case functions are used together to count occurrences of mathematics and non-mathematics subjects for each teacher. The condition sum of case when subject not equal to mathematics, then 1 else 0 and $0 ensures teachers exclusively teach mathematics, while sum of case when subject $mathematics. Then 1 else 0 and 0 ensures teachers teach mathematics subjects. And that's it. This SQL query also fetch us all mathematics teachers who teach only mathematics and no other subjects. Let's run the code to see the result. There you have it. We got the same result. All right. Let's jump into another question. And the next question is, how do you validate newly added column data in a target table as part of ETL? All right. First, understand this question. Now imagine you have a target table. Let's say a sales table with columns like order ID, product ID, and quantity. Recently, you added a new column called discount. and you want to make sure the data in this new column is accurate. Okay, first we have to understand the expected data. The first step is to know what data we expect in the discount column. For our example, let's say if the quantity is greater than 10, the discount should be 5%. Otherwise, it should be 0%. Next, we need some test data to work with. We'll create a few test records that represent different scenarios. Some with quantities greater than 10 and some less than or equal to 10. Now let's have a look at the table. Sales data. Here we have order ID, product ID, and quantity, and a new column called discount. Now let's write a SQL query to validate the discount column in the sales table. Now we start by using a common table expression, CTE, called discount CTE to calculate the expected underscore discount for each row in the sales table. And the CTE is defined using the with keyword. It works like a temporary table that holds the intermediate results. And in the CTE, we select specific columns from the sales table, order ID, product ID, quantity, and discount. Additionally, we create a new column called expected underscore discount. Here, the case statement is used to determine the value of the expected discount based on the quantity for each row. If the quantity WOD is greater than 10, the expected discount is set to 5%. Otherwise, it is set to 0. From sale data, now we will write main query. This main query is executed after the CTE is defined. In the main query, we retrieve the data from the discount CTE. The select clause specifies the columns to display in the result set. We include order ID, product ID, quantity, expected discount, and the original discount column, which we also name as actual underscore discount. Here, we use another case statement to compare the expected discount with the discount column for each row. If they are equal, the validation result is set to pass. Otherwise, it is set to fail. This query calculates the expected discount based on the quantity of each product and then compares it with the actual discount provided in the sales table. The validation result indicates whether the expected and actual discounts match or not. Now we can run the above SQL query. Let's interpret the results of our query. And there you have it. You can see the validation results. It shows us the order ID, product ID, quantity, the expected discount based on our conditions, the actual discount from the target table, and the validation result to see if it passed or failed. So this is how you validate newly added column data in a target table as part of ETL. I hope you understand this, and if you have any questions or suggestions, please do not hesitate to ask in the below comments section. If you found this video helpful, give it a thumbs up, and we'll jump into another question. And the next question they asked is, how do you compare data between source and target when we have millions of records? Manually, without automation. So when we have millions of records, manual comparison can be tedious and prone to errors. So let's see how we can perform this comparison more efficiently using SQL. Okay, first understand the scenario. Imagine you have a source database with customer information and you've migrated this data to a target database. Now, we want to ensure that the migration was successful and that there are no discrepancies between the two datasets. The first step is to export the data from both the source and target databases. You can use tools like SQL Developer to do this. Export the data to CSV files, making sure to include the relevant columns for comparison. And we need to understand the data and identify unique identifiers for each record, such as customer IDs. This will help us in comparing the data accurately. Now comes the exciting part. We'll write the SQL query to compare the data between the source and target databases. Let's write SQL query to compare data between source and target databases. Here, first we are writing an SQL query to compare data between source and target databases, and then we will break it down step by step, okay? Let's break down this SQL code step by step. The code starts with the select keyword, which tells the database that we want to retrieve specific columns from the tables. In this case, we want to get information about the customers, so we specify the columns we're interested in, customer ID and name. The from clause specifies the tables from which we want to retrieve the data. Here we have two tables, source_customers and target_customers. These are the source and target databases, respectively. The full outer join is a way to combine data from both tables based on a common column, in this case, customer ID. The join condition connects rows from the two tables that have the same customer ID. The AS keyword is used to give aliases, shorter names, to the columns we select. In this code, we're giving aliases to the customer ID and name columns from the source customers table as source_customer_ID and source_name, respectively. Similarly, we're giving aliases to the corresponding columns from the target_customers table as target_customer_ID and target_name. The where clause filters the rows based on certain conditions. In this code, we have three conditions connected with the OR keyword. The first condition checks if the name column is null in the source table. The second condition checks if the name column is null in the target table. The third condition checks if the name column is different between the source and target tables. Let's execute the SQL query and see the results. It shows us the customer IDs and names that have discrepancies between the source and target databases. Here, if a customer with ID 2 has the name Alice in the source database, but in the target database, the same customer ID has the name Alicia, this query will return that row because the names don't match. After getting the results, you would need to validate and handle the data discrepancies. You might update the records in the target database to match the source database or investigate further to identify the cause of the differences. That's it. The code helps you compare data between source and target databases and find discrepancies between the two. However, manual comparison can be time-consuming for millions of records, so using automated tools or scripts is a better approach for large data sets. And now we will jump into another question. And the interview question is, how do you validate the data when moving it from a flat file to an Oracle database during the ETL process? So, let's find out the solution. ETL is a process used to move data from one place to another while applying necessary transformations. In our case, the source is a flat file, and the target is an Oracle database. Let's say we have a source flat file containing information about students, including their names, ages, and grades. Before loading this data into an Oracle database, we want to validate it to ensure that all student names are not empty, ages are greater than 0, and grades are within a specific range. Here's a simple Oracle SQL query that demonstrates how you can validate the data during the ETL process. Here, I am assuming the source flat file data is loaded into a staging table called staging_students, and the target Oracle table is called target_students. Now, this query first selects all the records from staging_students table and using where clause it checks for empty student names in the staging_students table. And next query fetches all the records from staging_students table and using where clause it checks for invalid ages. And the third query checks for grades outside the valid range using same where conditions. All right, now we will run these queries and see the results. In the above SQL queries, we are performing data validation checks on the staging_students table, which is the intermediate table. If any records are returned by these queries, it indicates that the data in the flat file doesn't meet the validation rules. Before loading the data into the target_students table, the final Oracle table, data issues must be resolved, such as updating missing names, correcting invalid ages, or handling out-of-range grades. That's all. If you have any questions, please do not hesitate in the comments section. Let's dive into another interview question. Okay, next question is, explain about Factless fact table. Let's start with the basics. In the world of data warehousing and business intelligence, a fact table is a central table that contains quantitative data, facts, about a business process or event. These facts are typically numerical measurements or metrics such as sales revenue, quantities sold, or profit. Now let's move on to the concept of a factless fact table. A factless fact table is a type of fact table that captures the occurrence of events or activities without containing any numerical measures. In other words, it records the existence of an event but does not store any specific quantitative data related to that event. To understand this better, let's use a real-time example. A university attendance tracking system. Suppose you are designing a data warehouse for a university, and one of the important processes to track is student attendance. You want to keep a record of when a student attends a class, but you don't need to store any specific metrics like the number of classes attended or the total attendance percentage in this particular table. Let's have a look at the factless fact table. Here's what the factless fact table might look like. In this example, the date column represents the date of the attendance event. Student ID identifies the student who attended the class. Course ID identifies the course for which the attendance is being tracked. Attendance status indicates whether the student was present or absent. You can see that this factless fact table captures each attendance event without storing any quantitative measures related to attendance. So why would we use a factless fact table? Factless fact tables are useful for capturing and monitoring event occurrences. In our example, we can analyze trends in student attendance for different courses and dates. Performance and space optimization. Storing only event occurrences without numerical metrics can help save space in the database and improve query performance. Factless fact tables can also be used to ensure data integrity and enforce business rules. For instance, you can prevent duplicate attendance records for the same student in the same course on the same date. Remember, the main idea behind a factless fact table is to track events or activities without numerical measures, making it a valuable tool in data warehousing and analytics, especially when you need to focus on event monitoring and data integrity. And that's it about factless fact table, and let's jump into another question. And the next question is, what is referential integrity? Referential integrity is a crucial concept in the ETL process, which ensures that the relationships between data in different tables or databases are maintained accurately during the data integration process. Let's break it down with a real-time example using a simple analogy. Imagine you have two friends, John and Lisa. John is a book lover and Lisa is a library manager. Lisa keeps track of all the books and their authors in a library database. Now let's consider two tables in the database. Here we have two database tables, books table and authors table. In this example, the author_ID in the books table is a foreign key, which means it refers to the primary key author_ID in the authors table. The author_ID in the books table is used to identify the author of each book. Now let's discuss referential integrity in the context of this example. Referential integrity means that whenever a new book is added to the books table or an existing book's author is updated, it should always have a valid reference to an existing author in the authors table. In simple terms, you can't assign a random or non-existent author_ID to a book. For instance, if John loves a book and decides to add it to the library's database, he must provide the correct author_ID of the book's author. If the author doesn't exist in the authors table, Lisa won't accept the new book entry. Similarly, if an author's details change, for example, nationality update, the corresponding details in the books table should also update accordingly. Let's see how referential integrity helps in maintaining data consistency, prevents orphaned records. If an author is removed from the authors table, all the books associated with that author in the books table should also be deleted or updated to a valid author. This prevents having books without a known author, which we call orphaned records and data accuracy. When you query the database to find the author of a book, the database will always provide the correct author's details because it maintains the referential link between the books and authors tables and avoids inconsistencies. Without referential integrity, you could end up with books linked to incorrect authors or authors with no associated books, leading to data inconsistencies and errors. In summary, referential integrity ensures that the relationships between data in different tables are valid and consistent, just like Lisa ensures that every book in her library is correctly associated with a known author. It helps in maintaining the quality and accuracy of the data, making it an essential aspect of the ETL process. And that's all. We have covered total 8 interview questions from the latest ETL testing interview. Thank you for tuning in to learn about important ETL testing interview questions and answers. I hope you found this video helpful for your preparation. Stay tuned for our upcoming video where we'll delve into even more insightful interview questions. Don't forget to like, subscribe, and hit the notification bell so you won't miss out. Keep mastering your skills, and best of luck in your future interviews.